Now, okay, the class isn't recording now. Very good. So this is what we have covered up to this point. Going to the next one. Okay, right? Writing a chemical reaction. How do we write a chemical reaction? Any chemical reaction, right? Say for example, this is the one we are talking about. A chemical equation represent a chemical reaction. If you recall formula of magnesium oxygen and magnesium oxide, the above word equation can be written as, so which one we are talking about here, right? We know that magnesium ribbon, right? I believe this experiment was done by Urmi ma'am last year. Magnesium plus oxygen, okay, gives you magnesium oxide. This is the word reaction, magnesium oxide. This is the word reaction. Now imagine that all the chemical reaction that happen around us that we want to study, we have to write it in words every time. How much time it will consume, isn't it? Also, we won't get information how much of how many atoms of magnesium or oxygen are being used. We won't recognize what is this compound being formed, magnesium oxide. How will it, like, what will be its representation in terms of chemical formula? We don't know that. But if we use the chemical formulas, if we use the symbols, right, then the same equation becomes very easy. The same equation becomes very easy, which is this one, right? Mg plus O2 becomes MgO, magnesium oxide. You remember in ninth standard and even before that, you have studied this chemical reaction, magnesium plus oxygen, where you have to clean up the magnesium strip, and when you expose to heat in presence of air, it burns with a very bright flame and gets converted into ash. Have you done that experiment? Have you seen that experiment?
Yes, sir.
Yes, sir. Yes,
Okay,
sir.
who did it? Who did that for you? Which teacher explained that part to you? Yeah, who?
Urmi
Which?
ma'am.
Urmi ma'am had shown it to you. Very good, very good. Urmi ma'am had shown it to you. Very good. So, and then we will study about what the properties of everything. But important is, if we write, instead of writing the whole name, right, in words, instead of that, if we do it this way, the symbol, then it becomes very easy. Okay. Same way, this example, this particular reaction is showing the reaction between nitrogen, hydrogen, and which results into ammonia. Let me write the equation for that also. Okay, I'm going to use another slide here. So nitrogen, right, plus nitrogen plus hydrogen, okay, gives you ammonia. This is the chemical reaction in words. From this equation, from this word equation, can you tell me how many atoms of nitrogen are being used, how many atoms of hydrogen is being used, and how many atoms of ammonia are being produced? Can you say it from this?
No.
Right.
No.
How, who can give me the symbols of all the three compounds or elements being used here? Can somebody write it for
For
me?
night.
Yeah, in the chat box, or you can try it here also. You can annotate here, no problems.
Sir, N for nitrogen,
Just okay, let's see. N for nitrogen, very good. Then
H for hydrogen,
very good. Okay,
and NH4 for ammonia.
NH4. Okay,
NH.
okay, right. How many of you agree to this, students? And can somebody please tell me whether it is correct or not? Virmit, can you please tell me whether it is correct or not?
NH3.
NH3. Very good. That is the correct one for ammonia, right? Ammonia compound, that is NH3. Very good. Okay, what about nitrogen and hydrogen? Can we ever see a single nitrogen or a single hydrogen? This shows when you don't say, comment anything on single nitrogen and hydrogen, it shows that you haven't read what I asked you to read in the previous session. I told you very clearly to read chapter 3 one more time. That was on Monday. Today is Wednesday, right? If you had read it, you would know that nitrogen, what kind of element is it? What kind of, is it monoatomic, diatomic, polyatomic? What? Nitrogen? Anyone? Yes? Can somebody please speak up? Yeah? Diatomic. Very good, Virmit. Good job. Tanuj also is saying it should be nitrogen 2, right? N2, it should be N2. Same way for hydrogen, H2. We cannot have single nitrogen or single hydrogen in a free as a free atom, right? It will always be in this state, nitrogen, dinitrogen. Okay, get it, everyone? Yes, it is always diatomic. Okay, now, so I'm going to write this equation in terms of formula now. So nitrogen plus hydrogen gives you ammonia, right? Yes? Yes? Somebody wanted to say something? Feel free to unmute yourself. I haven't muted any of you. Come on, speak up. Do you agree to this? Nitrogen plus hydrogen is equal to, it gives you ammonia.
Yes, sir.
Very good. Why are we not writing equals here in terms of mathematics?
Because this equation is unbalanced.
Yes, even if it is balanced, we never write equal, right? We never write it
This
in
is
terms of
reversible.
equality. This is chemical reaction. Even if it is a reversible equation, we will write it this way and not the other way. Okay, always remember this. Okay, we never use the equality sign in chemistry unless it is an example. Okay, now as you can see in this reaction also, we have discussed this one. The atoms, elements, or compounds on the left hand side, they are called as reactants. Yeah, okay. And whatever is on this side, on the right hand side, it is called as product. Yeah, okay, or products, right? Any question on this
Yes, sir.
one? Products. Okay,
No, sir.
all clear? All
Yes,
clear on
sir.
this one? Very good.
Yes, sir.
Yes, sir.
Okay, going back to the PPT. Yeah, okay. So here we have presented in terms of or rather it's a pictorial presentation of ammonia. But look at this one, the chemical reaction in terms of pictorial presentation, right? They have used 3 hydrogen molecules, that is 6 hydrogen atoms, 1 nitrogen molecule, 2 nitrogen atoms, which will result into 2 ammonia molecules, which is 2 nitrogen and 6 hydrogen atoms. Okay, right? So going back to the whiteboard, right? So when we balance this reaction, because nitrogen is 2, hydrogen is 2, right? Hold on a second. Mhm. Yeah, okay. Nitrogen plus hydrogen gives you ammonia, right? Now we have to balance the equation. So how many nitrogen do we have here? Only 1. And how many nitrogen do we have here? 2. So obviously
2.
we have to make 2 nitrogens. If we make 2 nitrogen here, right, then this 2 on the outer side, right? On the left hand side of the molecule, it means there are 2 nitrogen and there are already 3 hydrogens. So 2 times 3, that is 6 hydrogen. Yes, understood? Do you understand what is the significance of writing a number onto the left of a molecule? Guys, at least say yes or no, please, so that I can.
Yes, sir.
That's better. If you have any question, please let me know, right? Okay, so we have got 2 molecules of ammonia, right, which has 6 atoms of hydrogen. Now in the reactants, we have got only 2 hydrogens, so we have to make it to 6. How do we do that? By multiplying it by 3. Okay, understood everyone? This is how we balance a reaction. Yes, everybody is clear on this one? I want
Yes, sir.
I
Yes,
want
sir.
a
Yes, sir.
unanimous yes.
Yes, sir.
There are 16 students in the class.
Sir. Yes, sir.
Everyone. I,
Yes, sir.
I want a
Yes,
yes.
sir.
Good. Is there
Yes, sir.
anyone
Yes,
who
sir.
has not understood up to this point? Is there anyone? Harshil, Keshvi, Naisa, Swara. Any question? Any
No,
question up
sir.
to this point?
No question, sir.
No,
Sure?
sir.
Sure. Are you
Yeah,
are,
yeah.
Yes, sir.
are we all
Yes, sir.
clear on to this one?
Yes,
Any
sir.
If you have any queries, just let me know so that we can resolve those queries at that very second itself. Otherwise, it will be trouble. Yeah? Okay? All good?
Yes.
Yes, sir.
Okay. Okay. All right then. So going back to the PPT. So writing a chemical reaction. Yes. Balancing a chemical reaction. These are the theoretical steps how to balance a chemical reaction. First, draw boxes around each formula. Do not change anything inside the boxes while balancing the equation, right? You cannot change the given formula. Always remember that, right? You cannot change the atoms or the molecules that are involved in the chemical reaction. You cannot bring something from the outside. You can only change the coefficient or the previous number. Okay, less the number of atoms of different elements present in the unbalanced equation, just like we did for ammonia, right? Start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Always you start with the biggest number and then you come down. Basically, this is purely about finding a common factor, है ना? HCF, right? Yes, everyone. And these are very simple numbers that we are going to deal with. Okay, everyone?
Sir,
Yes.
it is also said that you need to balance the atoms other than oxygen and hydrogen. And at last, then you balance oxygen and hydrogen.
Yes, usually hydrogen and oxygen, they are balanced in the last. Now that becomes a bit tricky when you have only 1 or 2 molecules other than hydrogen or oxygen present in the equation, like in the case of nitrogen and ammonia, right? We started with hydrogen. Yes, same way it will be applicable for carbon dioxides, right? When we talk about compounds that contains carbon and oxygen, it will be a bit tricky. So let's, like I said, preferable way is to go for the element which has the highest number of atoms, right? Element or compound. Okay,
Okay.
right? This is purely like the best way to handle this is by trial and error. And in trial and error method, practice, that's what matters, right? If you do enough practice, then any equation will be very easy for you, right? Look at this example. Hydrogen plus oxygen gives you water, right? So here in this case, how will you balance it, right? Balance the unbalanced atoms. Finally, to check the correctness of the balance equation, we count atoms of each element on both sides of the equation, right? Now, a chemical reaction or a chemical equation should provide information, and in a single line, if you want to accumulate more information, then you have to mention the state of the matter, right? That also you can do, the catalyst used, right? All those things you can mention. This is the one. To make a chemical equation more informative, the physical states of the reactant and products are mentioned along with their chemical formula. The gaseous, liquid, aqueous, and solid states of reactants and products are represented by the notation Gl, aqueous, and S respectively, right? The word aqueous is written if the reactant or product is present as a solution in water. Yeah, clear on this one, everyone? Some of the, especially some of the salts that we deal with, that we have seen, they will be soluble in water and then only the reaction will occur. So there we will have to mention AQ, aqueous. Yes, all clear on this one?
Yes.
Only one student is present in the class, is that so?
It's clear.
Yeah, okay, all right.
Yeah.
Right. So there are different types of chemical reactions that we will be discussing, but before that we will do some practice, है ना, of balancing the chemical reaction. Open up the notebook and textbook. Come on, everyone. Everyone, open up the notebook and textbook. Come on. Are you ready with the textbook?
Yes, sir.
Very good. Go to the first chapter and find this point. Go to page number 3. Go to page number 3. I'll be sharing it on the screen. There we are, right? Zinc plus sulfuric acid gives you zinc sulfate plus hydrogen. This is one of the chemical reaction that that you have studied in 8th standard also. Metals and non-metals, when you studied, right? Metals react with acid to give the corresponding salt, and hydrogen gas is liberated, right? So symbol of chemical symbol of zinc, that is zinc Zn. H2SO4, that is H2SO4 here, right? Sulfuric acid. Zinc sulfate is ZnSO4, and hydrogen is H. Now please be very careful the way it is written. Look at this one, right? This is very important part. Zinc sulfate S. Even though zinc and sulfate are separated, right, we don't write the capital S. You have to take care of this part also, right? Okay, everyone.
Yes, sir.
Now look at the
Yes, sir.
balancing. Look at the box. The box have been prepared. We have written down the different elements. And how do we start? Number of atoms in reactant, number of atoms in products. Is there a change? Is there a change required?
No, sir.
No. So that equation is balanced, right? Now what we have to do is, like I said, you will have to use the symbols, right? You will have to use the symbols. So properly balanced equation of this one will be zinc as in solid, okay? H2SO4, it's an acid, but we do not use acid in the dry form or in the gas form. It is always dissolved in water. Yes, right? So H2SO4, yes, everyone, what will be the state?
Yes, sir.
Aqueous or
Yes,
liquid? Acid is in liquid state or aqueous?
aqueous.
Aqueous or liquid? Tell me.
Aqueous.
Sorry? Yeah? Come on. What will be its state? Aqueous. Very good. Right? Aqueous. Right? And the arrow then zinc sulfate. Zinc sulfate plus hydrogen. Right? Now what will be the symbols with ZnSO4? Zinc sulfate and H2. Zinc sulfate, in what form will it be? Yeah, come on.
Solid.
Solid. Does it precipitate? Yes, very good, Virmit. Zinc sulfate will be in the aqueous form. It is dissolved in the water. Sorry, aqueous, not Ag. My bad. And hydrogen will be in the form of
Yes.
gas. Very good. So small g, right? Small g in the bracket. Yes, everyone?
Yes. Yes.
Very good. So that will be a properly balanced equation. Okay. All right. Now look at this one. Fe plus H2O, Fe3O4 plus H2. Now this is very important. Now this equation is of what? You have studied in 8th standard. This is equation of what? Yeah. What is this equation for? Iron plus water gives you iron oxide plus hydrogen gas. There was one very interesting term in the 8th standard chemistry for this, starting with R. And yes, very good, Virmit. I see somebody has studied at least. Anyone else? Harshil? Arya? Keshwi? Anyone? Meet? Very good, Meet. Good job. It is the equation of rusting. It is the chemical reaction of rusting, right? So Fe will be solid. Now H2O, in which form will it be? Will it be liquid? Will it be gas? H2O gas. What is the word for H2O in the gas form? Ved Soni. Yeah. Anyone? H2O in this equation will be in which form? Liquid or gas form? Water vapor. Yes, and water vapors are what? They are gas form. Very good. Very good. Right? You don't need liquid here. You just need vapors of it. Yeah. Okay. So what do we have here? Fe plus H2O. Here's Fe3O4 plus hydrogen. Now in this one, what will you do? Right? The reaction is written to balance the chemical reaction. First, draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Now the formula. Right? Now somebody was talking about use not starting with oxygen. Right? So we have to be very careful here. Select the element which has the maximum number of atoms. Using this criteria, we select Fe3O4 because that is the one with maximum number of atoms. Okay. How many oxygens are there? 4. How many ferrous? 3. Right. So we have to arrange it. Atom of oxygen. To balance the oxygen atoms, first you have to calculate on the both sides. Right. Here only we have got H2. Here we have 4 oxygens. So how many oxygens do you need here? Obviously 4. That means 4 hydrogen oxide, dihydrogen oxide. Yes. Got it? Yes, everyone?
Yes.
Are,
Yes.
are you with me? Are you all with me?
Yes.
Right. Now remember, this is very important part. You cannot write it like this, H2O4 or H2O4 times. If you put it this way, that means hydrogen becomes 8, right? Even this one is even here the hydrogen becomes 8, but that is fine. This one is a wrong way of writing it. Okay, you cannot write water molecule in this fashion. Okay, right? Then we go for, now we can go for hydrogen. Yes, so here we have got 8 hydrogen now. So and here only 2, so obviously 2 times 4, It can be done easily. Yeah. Okay. Yes, everyone. Are you with me? And the last one,
Yes,
which
sir.
last one to do is for Fe. That is very easy. So we have got 3Fe plus 4H2O gives you Fe3O4 plus 4 hydrogen. है ना? Now writing symbols of physical states. See, 3Fe solid, 4H2O gas, Fe3O4, the rust, iron oxide in the rust form is solid and hydrogen is liberated as the gas. Okay? Yes, everyone? Are you with me?
Yes.
Yes, sir.
Are you
Yes,
with
sir.
me? Everybody has understood this
Yes, sir.
point? Very good. You
Yes,
can
sir.
read this further equation, the further examples that has been given, that has been given to you, right? You can read it on your own, and once you do, that's when we will be writing this, answering these questions. Okay? Based on the names of the compound, you can do the solution. Okay? Yes. So these are the questions
Yes.
that you have to solve today. These three questions. These three questions you have to do today. Okay, and I'll be sharing some more equations for you to balance them out. All right. Any
Yes,
question?
sir.
Yes, sir.
Any
No,
question
sir.
up to the point?
No.
No.
Is everyone clear on this one? Kavya Jinduwadia.
Yes.
Is that Soumya?
Yes, sir.
Okay. So you both you both the brothers are attending from the same instrument or what?
No, sir, from different.
Then you can put your name, no? You can do that so that I don't get confused. Yeah.
Yes, sir.
And like I said, rest of you, Shivam, Keshvi, Rudra, Harshil, Srina, Samriddhi, and Arya, and Tanuj, please put your own display pic. Right? Next time, I will not allow you to enter the class. Is everyone clear on this one?
Yes, sir.
Yes.
Yes, sir.
Good, good. Okay, then I'll see you in the next session then. Right? Any questions up to this point? Does anyone have any doubts? Any question? I want
No, sir.
I want you to read it today and try those questions. Okay, right? So it can be changed. What,
Yes.
Harshil? Harshil, you are saying? What are you saying, man? It can't be changed. It can be changed. You have to log in. It's connected to Facebook. Yeah. So change the ID in the Facebook, or you can use your email, your Gmail ID. It can be done very easily. Okay, it can be done very easily, my dear. Or as an option, I need undisable. I don't know what you are saying. Another option is you keep your video on. That is the alternative. All right.
Okay, sir.
Good. Good. All right then. That's it for the day, everyone. Have fun. Take care. Bye bye.